Rational versus irrational numbers. All right, so we're going to talk about rational numbers first. So a rational number is a number that can be expressed as a ratio or a fraction. Here are some examples. We'll start off with these two. Obviously, 3/4 and 3/10, both of them are already fractions, so they're rational. But in their decimal form, 0.75, you have to be able to know I can go back and forth with that. Those are considered rational numbers, both of these examples. Let's take a look at a decimal, 8.45. That's 8 and 45 hundredths before I reduce it, but it doesn't matter. As long as I can make it a fraction, it's a rational number. How about an integer like 14? Well, any integer, I can always put it over 1 and make it a fraction. So all these can be written as fractions, so they're rational numbers. Let's take a look at a different type. 0.3 with a bar on top. If you don't know what that bar is, it just means to repeat. So that just means 0.3333. It just goes on and on and on. Those are considered repeating decimals. If I can tell what's coming up next, it's going to be, I can predict it, and therefore it's a rational number. Let's take a look at that are sometimes a little confusing for students. Like this really long number here that keeps on going. Well, notice that's 0.142857, 142857, 142857. So those numbers there repeat. So the fact that it repeats, I can tell what's coming up next, and that's going to tell me it is a rational number. This one happens to be 1/7. How about 0.666666 repeating? Well, it repeats. I can tell what's coming up next, and it happens to be 2/3. So if it's predictable, if you can tell what the next digit's going to be, then it's a rational number. Let's take a look at a different type. They're called terminating decimals. It means 0.4. It terminates. It stops right at 4. Right? This is 4/10. That can be reduced to 2/5. So the fact that I can write it as a fraction tells me it's rational. 1.8, it stops. Doesn't go past that. It's 1 8/10 or reduced to 1 4/5. Regardless, either way, you have fractions. So therefore, you know that it is a rational number. Here's the thing again. Is it predictable? Can you tell what's coming up next? 0.4, I can tell the next numbers are going to be zeros all the way through. It's predictable. It's a rational number. How about irrational numbers? An irrational number, it's a number that can't or cannot be expressed as a ratio or fraction. So here's pi. 3.1415, and it goes on and on and on and on. Okay, so it doesn't terminate, and there's no repeating going on. There's no pattern here that I can tell. So therefore, it's irrational. I can't predict what's coming next. How about the square root of 2? Well, if you put that in your calculator, you get 1.4142135. Notice it doesn't terminate. It doesn't stop. These are what the dots tell you. And there's no pattern. I can't tell you what's going to come next. This last one I just made up, again, it doesn't stop and there's no pattern, therefore it's irrational. So I'm going to go ahead and jump over back to our notes here. Your essential question of the day was, how do you determine if a number is rational or irrational? Disregard the little stuff that I crossed out there. We'll save that for another video. And then you can go and add down below that in Cornell note style your two vocabulary words, rational numbers versus irrational numbers. If you find that you need to write down terminating or repeating, feel free to add those to your list as well. I made a little graphic here for you so you could maybe understand this a little better. So in the world of real numbers, there's either rational numbers or irrational numbers. Remember, we talked about rational numbers being able to be written as a fraction. If you can write them as a fraction, sorry. They're rational, so all these are considered rational, including integers that you can always put a 1 underneath. Or counting numbers, again, put a 1 underneath, makes it a fraction. And then you have examples of irrational numbers. So you can also add that to your notes. Might look something like mine here, or you can just make your own numbers, but add that to your notes to move on. So how do we tell if a number is rational or irrational? Well, there's a couple steps you can take here if you haven't figured it out already. Step number 1, is it already a fraction? If it is, guess what? It's rational. Easy. If it's not, okay, you move on. Step number 2. If it's a decimal, does it terminate? Does it stop? Is it predictable? If you say yes, it does stop, I can tell what happens next, it's rational. If not, move on. Last step. Is Does the decimal repeat? Again, is it predictable? You'd say, yeah, it is, then it's rational. If you say no, then you know it's irrational. Okay, so let's use those steps to try to solve these next questions. So I want you to determine if each number is rational or irrational. Okay, 6.431 with no dots after that. Okay, so I ask myself, is it already a fraction? Nope. Does the decimal terminate? Yeah, it does. It stops right there. I can tell you all the next numbers are 0, so therefore it's rational. Let's take a look at this one. 4.3 repeating. Is it a fraction? Nope. Does it terminate? Nope. Does it repeat? Yes, it does repeat in a pattern. I can tell you the next number is going to be 3, followed by 3, followed by 3, on and on. So therefore it's a rational number. You can write that as a fraction, and next video we'll talk about how to do that. Let's take a look at this one. 6.1837946 ... Okay. Is it already a fraction? Nope. Does it terminate? Nope. Does it repeat? Not in any kind of pattern, so it's irrational. How about this one? The square root of 16. Well, it's important for you to know that the square root of 16 is 4, and 4 can be written as 4 over 1. So is it a fraction? Yes, it's rational. Before you finish the video, go ahead and write down the steps. You can either go back and use the video format, or I wrote it out for you here, following the steps. Is it a fraction? Yes or no. Does it terminate? Yes or no. Does the decimal repeat? Yes or no. You can add that to your notes. And then, as well as the examples, should look something like this. I believe I used all the same numbers. I'll zoom out here. Again, just asking yourself, fraction, yes, no. Terminate, yes, no. Rational, yes, no. I'm sorry, repeating, yes or no. So ask yourself those questions on those type of numbers, and hopefully that will help you out for your classwork today.